Hello students, welcome to the video on photolithography. So, in the previous videos, we have discussed about the other topics in the module 5, that is thermal oxidation, what is meant by chemical vapor deposition, rapid thermal processing, diffusion and ion implantation. So, in this video, we will be discussing about photolithography. So, photolithography is an important process or it is an important step in fabrication, IC fabrication. So it is a continuous process where it involves so many steps. So starting with the photolithographic process, the first one is take a substrate. It can be an either N type or P type record based on the application. So the substrate is coated with or it is covered with a silicon dioxide layer. So silicon dioxide layer will act as an insulator. Now we have the substrate with silicon dioxide. So now the next step is coat it with a photoresistive material. Photoresistive material is of two types. One is positive resist and other one is negative resist. Positive resist and negative resist, the application is that when this material is exposed to photons, that is when it is exposed to the light energy, it may get hardened or softened based on its electrical chemical properties. Now you assume that I have coated a layer of photoresist on the silicon dioxide layer. Now when I expose it to the light which is generated and which is enabled by means of a mask. So mask is a pattern which will be placed on the substrate. Now based on the mask, so the layer will be getting exposed to the ultraviolet rays or the for light energy, and it may be that particular layer photoresist may get softened or it may be hardened. So during the etching process, that unwanted layer will be removed and I will be getting a pattern mask. So in this diagram we can see that the silicon dioxide what is present throughout the layer because of photolithography, this is converted to this form, that is it is the photoresist material or the photolithography process will remove the unwanted oxide layer which is present on the surface. So for this, the main important thing is what is meant by the mask. So the mask is nothing but a pattern which will be deciding which part to be removed and which to be kept as such. So to study it in detail, we will go for the photomask CAD layout. What is photomask CAD layout? So this is the mask generation and the pattern transfer is going to be a tedious process and also a complex process which can be made easy by means of the CAD tools. So the CAD tools are used to draw the composite signals and also to transfer those patterns to the substrate. So this is drawn with a computer layout system and it can have one software or one state of art of a process can have for fabrication of CMOS can have about 25 masks or more than that. So the photo mask of the previous CAD circuit will be having a mask pattern like this, and it is used in step and repeat operation. That is, the same pattern will be repeated many times because this IC fabrication is in mass production where millions of transistors or at least thousands of devices will be manufactured at the same time. So this will be resulting in a thing called as reticle. So this diagram, it represents one mask, that is one mask for each photolithography which is to be processed now. So here this size is about 10 times of the original size. We can comparatively we can see that that mask is actually repeated for n number of time, and this is called as an reticle. So this is called as a step and a repeat operation. So 400 copies of this original mask is done for the fabrication of an integrated circuit. The mask is very precise and it is of very small size that a human hair will be having the thickness of this when compared to the mask. So we can see that this mask which I'm going to generate, which we are going to generate, will be of very small size. So it will be in the terms of hundreds of nanometers or smaller than that. So the mask alignment is nothing but how we are going to fix the mask or the pattern on the substrate or on the silicon surface. So the alignment will be done automatically by means of a photolithographic component called as the steppers. So the when compared to the when coming to the resistor are of two types. One is called as positive and another one is called as the negative resistor. So in this diagram, we can see here you are having a silicon substrate which is coated with a silicon dioxide material followed by the photoresist. On the photoresist, we have a mask. Mask is nothing but a pattern here which will be only for a part of the surface. Now, in a positive resist, after the photolithographic process, that is, after exposing and then cleaning and etching process, the part which is exposed will be, that is, the mask which is under the mask will be remaining as such, and the remaining part will be removed. But whereas in negative resist, the silicon dioxide surface which is there which is X or the photoresist layer which will be exposed to the light rays will be becoming hardened and it will remain as such, and the remaining part will be removed. So this is the output of the for this pattern this is the output of the photolithographic process. So the light sources can be either an ordinary electromagnetic radiation light waves, or it can be a beam of electrons, or it can be an X-ray also. Now, the next one is the printing technique. So, printing is nothing but where we will be having the the pattern, how it is going to be getting transferred. So depending upon the position of the mask, we can see that there are three types. One is called as contact printing, another one is called as proximity printing, and projection printing. Contact printing is nothing but where the wafer is in contact with the mask, whereas in case of my proximity printing, there will be small distance and it is in close proximity. Whereas in projection printing, light sources is scanned across the mask and it is focused on the wafer. That is, there will be large distance between the mask and the wafer. So there will be projection of this light, and because of this because of this lens, there will be again the light will be focused on the mask. So these three are the different printing techniques which will say how the mask is positioned with respect to the wafer. So the next one is what is meant by steppers. The steppers are nothing but the widely used system in the photolithography to position and to control the entire process. So this is a complex process, and hence it needs high degree of environmental control. That is, the system should be free of dust and the pollution. So it is there in their clean room. That is, the system should be perfectly cleaned with no dust particles, and it should also be free from the vibrations. So here we will see how a diode is fabricated using the photolithography. So first what will be done is you will be having a silicon dioxide material on the which the photoresist is uh, done. So the photoresist is pasted or it is coated by means of a spinner which will spin at a very high speed, and hence the coating process will be taking place. Next, place a P region mask. P region mask is nothing but in an n-type silicon where I want to diffuse my P region. So the remaining part is closed and only the region where I want here to be open will be exposed to the light rays. So because of that, the exposed region will get softened and the remaining photoresist will become hardened. So here we can see that in this diagram. So when I clean it, okay, so when I clean it with an acidic solution like hydrofluoric acid, so the exposed part will be removed, and then again I can do some chemical reaction process, and I can remove the silicon dioxide which is present here, and again I can go for the diffusion. So diffusion or ion implantation of an acceptor ion, that is a trivalent impurity. When it is done, so I will be getting a p-type silicon. So this is an n-type and p-type, and hence a diode is formed in this case. So here we have discussed about the photolithography process. Thank you.